So we got a couple of other problems that we're gonna finish today. And I'm gonna leave this one. We got another one down already together. Yeah, everything else is, let's start here. Let's just start here with these multiple choice questions. And we're just gonna walk them down and answer each one. And then we'll move up. And there's a couple other problems we'll do. And if we finish early, so be it. All right, what about that first example? Somebody tell me what reaction is that? Like first of all, what are we doing as far as like, what are reagents and what is the outcome of putting those reagents together? And again, the key to these reactions is knowing, sorry, it's a lag in there somewhere. Your functional groups. You have a carboxylic acid in the presence of an alcohol. What am I going to get? And by all means, you can look at the answer choices to figure that out, but you should already know that.
So would it be the first one at the top left?
This one?
Yes.
What functional group is that I just circled? That's an acetal, isn't it?
Yes. Oh, but there's only 1 mole of it.
One mole, and
Oh.
the carbonyl is not the right type of functional group, is it?
Nope.
I need an aldehyde or a ketone. And that's a carboxylic acid, right? So it's not gonna give me an acetal or a hemiacetal. So there's only, well, that's two choices left, but this is not going to happen. There's no other oxidant in there to make another carbonyl show up here.
Right.
So again, carboxylic acid plus an alcohol or an acid chloride plus an alcohol is going to give me ester. All right. That's now the next one. Let's go to the next one. I got 2 moles of alcohol and a ketone.
Right. So now since it's 2 moles, would it be the how do you say acetyl?
Acetal.
Acetal.
Yeah.
We would get an acetal.
Yeah. Right. And then you really have here, you can get the acetal, which is this is the correct answer. Right. But there's the hemiacetal is here. But that only happens if I only have 1 mole of alcohol and not 2. All right, so the hemi is 1 alcohol plus an aldehyde or ketone. Acetal is 2 plus aldehyde or ketone. Right, and again, it's all about recognizing the functional groups. You've got to recognize what functional group you're dealing with in order to understand what process is getting ready to happen. All right, what about the last reaction? What kind of reaction is that? This is the giveaway right here. Phthalate. It's a dead giveaway for the type of reaction. It is.
If you have a phthalate, then wouldn't you get the Vidded reaction?
No, not with phthalate. Phthalate is used in another type of reaction to make amines. Just think about the angel that talked to Mary and told her that she was going, it's almost Christmas, so yeah. But Gabriel synthesis, right? That's a a way to make amines, right?
Yes.
So when you see this, that's a dead giveaway because it's this nitrogen right here that's going to displace the halogen in the alkyl halide. You need dialamide, an alkyl halide, strong base, and then water. So over here, immediately this is how you make amines. So I'm looking the answer. What am I looking for? I'm looking for an amine.
That NH,
Right.
yeah.
So that's my amine right there. And in this case, it's a secondary amine because I started with a secondary alkyl halide. All right. So this is the Gabriel synthesis allows me to make primary and secondary amines. All right. Let's go to any questions about these reactions before we move on. All right. Let's go to this set of reactions right here. I'm gonna start with this one. All right, look at your functional group that you're working with. You starting with a primary alcohol, and then you're gonna react that with potassium permanganate, which is a dead giveaway, water and sodium hydroxide. But this is the main reagent right here. So what is that going to do to that alcohol? And what type of reagent is that? It's an oxidant, am I right? One of the oxidation methods that we've studied. We talked about Swern oxidation. We talked about chromic acid oxidation, and we also talked about using potassium permanganate, and we talked about using TPAP and NMO. Those are 4 methods that we talked about for oxidation. So what does potassium permanganate do to primary alcohols? When as a matter of fact, let me back. Go ahead.
Does it turn into carboxylic acid?
Yes, it's gonna oxidize it up to the carboxylic acid. It's not gonna stop at the aldehyde because again, potassium permanganate is what was considered a superoxidant. So it's gonna keep oxidizing that carbon up until it gets to its highest oxidation state, which is in this case having 3 bonds to oxygen. All right, so that's going to be the product from that reaction. It won't stop at the aldehyde. It'll keep going until you get to the carboxylic acid. All right, what about the next set of reagents? And again, I'm starting with a primary alcohol. I have chromium oxide, sulfuric acid, and water. This is the precursor to chromic acid. Let's go back up to the top because all these reagents are already listed in that. Let's see, where are we? Next page. Right here. So you can see that the chromic acid is here, H2Cr2O4. So the precursor to that, just skip down. Is this. So H2Cr2O4, right? These are the reagents that you'll add together to make chromic acid. But the point is, what is chromic acid and what does it do to primary alcohols?
Is it the oxidation followed by like the Vidic reaction?
Well, there's no subsequent reaction here. It's just the oxidation. But
Oh,
you're right. You're right about the oxidation. If it was followed up by Vidic, we would write it as a sequence. So this would be 1, and then the Vidic stuff would be 2, right?
right.
We don't have that. We only have the chromic acid. So that's going to take that alcohol and oxidize it up to an aldehyde. Make sure I get this. All right, so that's my final product. Anytime chromic acid is in the presence of a primary alcohol, it's going to turn it into an aldehyde, like so. All right, let's go to that last problem. It says predict the products and propose a mechanism. What functional group am I starting out with? Right here.
Is this where the epoxide opening happens?
Good. Yes, this is an epoxide opening reaction. That's exactly right. Right, and then it's the LAH, which is going to provide the nucleophile to pop it open. So it's really just going to be not a proton, a hydride that's going to come in and attack that epoxide. So this is coming here, and this is coming here. It doesn't matter which side it opens because the epoxide is symmetrical. So I'm going to get an intermediate that kind of looks like this. It's negative. And then I have the hydride that I added in here. There's already 1 hydrogen there also, right? So I'm just pointing out that that's where the hydride went. All right, and then in the next step, the water step, that's just a quench, right? So I'm just going to add in H+, and that's going to give me this. So one of the methods for making alcohols is to open epoxides using some nucleophile. But again, those epoxides they look unstable because it's a highly strained 3-member ring, but you'd be surprised at how robust they are. They can hold up under a lot of different conditions. All right. Let's do this problem right here. It says predict the products from the following reaction, propose a mechanism. So you have the mechanism down below, but what would the product be from this reaction? And what type of reaction is it? Again, when you see triphenylphosphine,
You think of a Vidic reaction?
Yes. And you have an alkyl halide. This is going to be a Vidic reaction. All right. How do I predict the product for that?
Well, doesn't it just turn into an alkene? So we're replacing that. We're replacing the bromine with the oxygen and making it alkene.
Okay, so let's look at again, let's look at our little shortcut method. So this is my alkyl halide. right? And I want to subtract from this, from the carbon where the halogen is, which is that one. I want to subtract out H and bromine. So what am I left with? I'm left with this, right?
Yes.
Mhm. So this carbon that I have highlighted is what's going to replace oxygen.
Oh, and then you would attach the CH3 and the hydrogen to make the alkene.
Okay. So let's do that. So let's say here, this is my double bond for my aldehyde. But now, instead of oxygen, I'm going to attach that carbon. Let me get a better angle. I'm trying to write on the screen without touching it with my palm. All right, so now that is the product because it's that carbon right there that's going to replace oxygen. All right, so that's a major product. And then the oxygen, we're going to see down below it in the mechanism, but the oxygen ends up here. Right. So let's see if we can walk through this the mechanism. Any questions about that before we put the arrows in down below? All right. Let's go to here. So how do I go from here to here? And what's the name of this species right here? Right, you can't do a video without this particular species. What's it called?
I don't know how to say it.
There you do. You said it right the second time. It's an illid. Think about pronouncing it like that. So think of the Y as, or the YL as ILL. So it's an illid.
Illid. Okay.
All right, so that's my illid. What does it do? Like, how do I go from the illid plus the aldehyde or ketone to this? I'm gonna write this in. Remember, we discussed this, that this has been to the beta. We talked about this, right? And we talked about how there's been some further research done that kind of disproved the existence of the beta E. But for the purposes of discussing the reaction, this intermediate makes it a lot easier to talk about what happens after you get to that stage. So how do I get there? You can see I have a bond, obviously, between this carbon right here and your aldehyde.
So does the illid like kind of work as like for nucleophilic attack? So it's going to attack the that carbonyl
Yes.
group.
Yes, that's exactly what it does. So that pair of electrons on carbon is going to attack the carbonyl, right? So I end up here. And then how do I get from here to here? This is another intermediate.
Do you have to do a proton transfer?
No, look at what happened. There's no protons that move, but I have a bond between phosphorus and oxygen on the right side of the arrow that I didn't have on the other side. So that's that again. Let's think about what happened. How did I do that? I got a negatively charged oxygen and I have a positively charged phosphorus. So
was there an elimination that took place?
Well, that was okay. Let's think about that. If there was an elimination, there'd be a pi bond somewhere, right? because that's the
Right.
hallmark of an elimination. But
Right.
you can just simply add or push a pair of electrons to, or donate a pair of electrons to phosphorus and make that PO bond right there.
Okay. I
Mhm.
see what you did. Okay.
Mhm. All right, so now we gotta, this intermediate is where my product comes from. So it's gonna break down or decompose. So decomposition, that's what's gonna give the, of this, it's gonna give me my alkene. So I wanna put a double bond right here. That's the goal. How can I do it? Using only what I have right there.
You can't take the, well, no, you can't do that. Mm.
Think about it. Now we talked about this before. I want to put a pi bond here, and I want to put a pi bond here. Need electrons to do that.
We need electrons that are willing to transfer to become a pi bond.
Where can I get them from? I don't have any external, so it's got to come from inside. It's got to be intramolecular. So where am I getting these electrons from?
Hydrogen, alpha hydrogen.
I don't have a base to pull it off. But I do have these sigma bonds right here that I can break. And that's how the decomposition happens, right? This bond is going to come here. And then this bond is coming here. So we're going to break those two sigma bonds. And that's going to give me this product. And it's also going to give me this product. Right, which is the same, the alkene I had drawn up top. Right, so that's the Vedic mechanism. You go from attack of your illet on your aldehyde, and then you end up at the oxyphosphatane, which is the 4-membered ring, and then that just decomposes. Right, you break the CO sigma bond and the CP sigma bond, and those electrons are used to make your pi bonds. You need a pi bond between phosphorus and oxygen, and you also need a pi bond between the two carbons. And the reason why that works is because making those pi bonds, like you always want to go from a weaker bonds to stronger bonds. So the reason that works is because you're making a really strong carbon-carbon pi bond, and you're making a really strong phosphorus oxygen pi bond. So that's what drives the reaction, because you're going from weaker sigma bonds to stronger pi bonds. All right, so that's a highly exothermic process. As a matter of fact, you have to do this at low temperature. I'm not sure, I can't remember if it's minus 78 or if it's like minus 10, but you're definitely running this on the ice bath, because that last step is exothermic. All right. Questions about the mechanism?
Dr. Russell, what was it called when we broke the two sigma bonds to get our product? What was that called again?
Well, it's just decomposition.
Oh, okay.
Yeah, it's just decomposition. So that decomposition is going to that's how that intermediate breaks down to give you your two products. But the alkene is your major product. And again, I think when we first talked about this reaction, I talked about doing it in inert atmosphere. That's on purpose too. Because if you got oxygen present, the triphenylphosphine, it'll get oxidized even before it, it's able to make the illite. That oxygen phosphorus bond is that strong that if there's any oxygen present, phosphorus is going to react with it and get oxidized up. So you don't want that. So you got to run it under nitrogen. I think when we talked about this, I showed that, where is it? I know I showed it. I put a flask somewhere and talked about it right here, having to do it under inert conditions. So you flush your round bottom out with nitrogen, flush out the oxygen, and then that way you don't destroy your phosphorus before you get a chance to use it to make the illite. So yeah, other questions? Any other questions about that process or about that mechanism? I think that's the last question that we're going to do because I know I left one. This one is the same. I'm going to make both of these. This is the same type of reaction. And I already have the illite down here. So it's just a matter of taking that plus that ketone.
Dr. Russell, do you think you can just like swipe through which ones we're supposed to do on our own? Because I don't have those.
It wasn't very many. So these two right here, the acetal reaction, and then the Vidic mechanism right here. Both of these are mechanism problems. We have to actually do the mechanism. But if you scroll up in the notes, the mechanism is there. So which other one did I think I had one more down here. And then the aromatic, the aromatics right here. That's on your own problem. Because we've done aromatics already. So
right.
You already have seen these reactions. And I think that was it. And then the only problem that's left is this problem right here.
Okay.
So this is a cyclization, but it's really an epoxide opening. So it says in the presence of strong acids, epoxides, which is the functional group that we have here, readily cyclize intramolecularly. Propose a mechanism for the cyclization. So what you have to understand in this case is a couple of things. The first thing is what intramolecular means, right? What does that mean when we say something happens intramolecularly?
It's gonna take place within the mechanism. I mean, within the mechanism.
Yeah, so the reaction is going to take place within the same molecule, right? So the nucleophile or whatever your reactants are, they are both in the same molecule. So in this case, if it's a cyclization, which means I'm closing this up to be a ring, I can see my epoxide. I got 2 carbons here, and then the potential nucleophile is going to be right here. It's going to be that hydroxyl group, right? So if I take that epoxide and treat it with H+, what am I going to get? What's going to happen? All right. And I know we've talked about doing proton transfer with the hydroxyl group to make water. But in this case, that water is not going to be a leaving group. Right. So if I add H+ to this, which one of those functional groups do you think is going to get protonated? I'm not trying to make water. I'm not trying to make OH a better leaving group in this case.
Wouldn't it be the epoxide because you're trying to open it up?
I'm trying to activate it. That's exactly right. So I'm going to add proton here. And that epoxide now is going to become positive. All right, and so now the question is, how does it cyclize? So I have my, again, let me show you, point out the carbons, because you see here we got a 6-membered ring. 1, 2, 3, 4, 5, 6. So over here, there's got to be 6 atoms involved. So where does the question is, which side does the hydroxyl group attack?
Could you say that again? I missed it. What did you say?
No, I'm saying we have a 6-membered ring as a product. And now we need to figure out which one of the 2 carbons in the epoxide that alcohol is going to attack.
Would it be the one that's immediately adjacent to it?
This one right here?
The
Or
next one.
Right here?
Mm-hmm.
Well, okay, so let's think about that. We're trying to open the epoxide. Will either one of those carbons attack at either one of those carbons cause that epoxide to open? That's the
Oh
first.
no, you have for the epoxide open, it's gonna be the carbon at the bottom.
Yeah, so I want to do this, right?
Yeah.
And in doing that, let me erase these other arrows. In doing that, now I've actually popped open the epoxide. So that's going to give me a 6-membered ring like so. Put my oxygen here. And epoxide was on these 2 carbons. So this is OH, and this is also OH. And that's positive. And remember, my H plus came from sulfuric acid. So now the conjugate base of sulfuric acid can just come in and do proton transfer there. And I'm missing a methyl group. So that's going to do proton transfer there. And give me the product, right? So this type of reaction is, again, another way to think about alcohols and how they react, because you can also use them as nucleophiles. So in this case, the nucleophile was here. It was intramolecular. So this became my nucleophile, and my electrophile is here, right? How would I get, let me see, how would I get this product?
Wouldn't you just have to open the epoxide from that other carbon?
Yes, that's exactly right. So if I wanted to, if I wanted the 5-membered ring, which you probably, in all honesty, you probably want to get a little bit of both, right? So if I wanted that 5-membered ring, then I would attack at this carbon right here. All right. All right, so we're actually gonna stop here. Go ahead, Quinetta.
I thought with the epoxide opening, it like depended on if it was acidic or neutral. Is that correct?
It does, but in this case, since it's, and that's why I'm asking about the hold up, I screwed that part up. It's actually gonna look like this. 1 second. It'll look like that. So yeah, it does matter. And that's why I'm asking about the 5-member ring, because you're gonna get actually both of those products. And the 5 is what you would expect, right? Under acidic conditions. Because that's the more substituted carbon. Is that right?
It's where it opens at, or like where it ends at?
No, where it opens. Because remember when we talked about epoxide opening, under acidic conditions, it's going to attack the more substituted site. Under neutral conditions, it'll attack the least substituted site.
Mm-hmm.
Yeah. So the 5-member ring is also possible under the conditions. Right? So you're going to get the 6 and the 5, but more than likely the 5 will probably predominate just because of the fact that you're doing it under acidic conditions. But it's going to follow the same mechanism.
Okay, thank you.
Follow the same mechanism. It'll just attack at a different carbon. All right. Other questions about that? I want to actually turn this into a good bonus question. So I want you to take this. Let me see if I can paste this here. Yep. I'm gonna post this. I'll post a link for this in the in that final reactions assignments folder. But I want you to show the mechanism of how you will make that 5-member ring. So just put the arrows in, just like we did for the 6. And I'll post a link for you to post that by the end of the day. But we're going to actually stop here because this is the last reaction that we're going to talk about. Unless there are questions, we're going to stop here, and then I'll post this bonus and let you up. I'll take it. I'll just leave it open all day, to be honest with you. So, but you see,
Dr. Russell,
go ahead.
I'm gonna send you that email today about the list that you talked about yesterday. On Wednesday.
Okay.
All right.
I have a question, but it's not about this assignment directly.
Go ahead.
So for the assignments, for everything that's due, it's under the assignment folder on Blackboard, correct? Those assignments that are there?
Yes.
Okay, and for the quizzes as well, because I remember in the beginning of the year, of the semester, we had the quizzes were all uploaded, and I was one of the people that did all of them, and you sent out the email saying that we weren't supposed to do that. So I realized that we had to redo them. So as for the quizzes, are they just the quizzes that are under the YouTube lecture pop quizzes, or is it more quizzes than that?
No, that's it. And those quizzes were, and let me explain that because the quizzes were intended for you to watch after you watch the video.
The video, yeah.
And then the same with the assignments. The assignments were posted. We worked through them in class, and then you turn them in on the day of the exam or the day after the exam. All right. So most of those assignments we've already, like, you can see just even with this packet right here, we worked through this whole packet.
Right.
So this is what you would submit, not necessarily all your notes and stuff, but the questions and any mechanisms that we did on this page. That's what you would submit for this next test. So we're supposed to turn assignments in after every exam.
Right.
Mm-hmm.
Okay,
So,
I
yeah.
was making sure because when I go to the grades portion, it looks like I'm missing so much stuff, but I'm realizing.
No, hold up. I'm glad you said that. I'm glad you said that.
Yeah, because I'm just really, I was just getting nervous.
Now let's clear that up because I sent
Yeah, I
out
also had a question about that because I've been like waiting for like the NMR like assignments, but they never pop up like on my Blackboard.
the NMR assignment.
Yeah, I've been waiting since like we
That
started
came up.
NMR.
Oh, that's already, and I put that handout in the chat multiple times when we were
No,
talking.
I mean not the assignment. I'm sorry.
You mean the
The
quiz?
quizzes. Yes.
Let me double check and make sure that it
Yeah,
opens.
I've been looking like daily for them, but they like never show up. So
Yeah, and I don't think I opened this final reactions quiz either, but I can open it now because that'll be a good way to test to see what you know going into that exam on Monday. Come on, internet, don't do me like that. Okay, went out. Oh, no, I didn't.
And yes, sir, Dr. Russell, I was having the same issue. The only concept with me was I was one of the people that did it early, and you sent me a note telling me that I'm not allowed to do that. So I was trying to resubmit it, but it wasn't allowing me.
Yeah, I thought I cleared all those out though. All the ones that were early, I remember clearing those out in Blackboard. So you might want to.
Yeah, because I have a grade for it. That's what I was confused about. Because one of them I had 1 point, and then you put on the note saying that I did it too early.
That was only like, I think I saw it was an NMR assignment that multiple people turned in early. And I'm like, how can we turn this in early? We ain't even talked about this yet.
I
So
took the class before, yeah.
yeah, I got that. I understand that, but you know, let me just go right here because I'm gonna.
Yes, sir.
And if there's an assignment that you need cleared so you can resubmit, just send me an email with which assignment it is. Because as you can imagine, this is so yeah, so all the handouts are here, right? Right here, I'm gonna let me go ahead and make this link. I had a Swearing oxidation, extra credit. That's done already though, but I'm gonna make this assignment for this mechanism to make this 5-member ring. It's a 10 bonus point question and display until 12. Yep. Perfect. All right, let me see about this. These quizzes. I could have swore I opened that NMR quiz. What a shame.
Yeah, like all those quizzes that are there. When I go to quizzes, the only quizzes that are there are.
Well, there's nothing showing right now because all the other ones are like were past due. So the only thing that I see that should be showing is
It's the SN1, SN2
yep,
quiz.
aromaticity, ranking nucleophiles.
Yes.
Yeah, that should be showing. The NMR quiz, let me open it. That's my fault.
So for the quizzes that I miss, is it possible that they could be open? Because I'm only completed because I remember completing them early in this semester, and then we had to redo them. But I just went back to the folder and completed them. So I don't have all these quizzes completed.
All right, let me see. Yeah, just send me a message, email about which ones you're missing.
Okay.
No, do I want that? Take all that. Yep. And then that final, I can't believe I forgot to open these up. But this one right here, I want to open. All right. So yeah, I sent, but I actually sent out an announcement the other day. Somebody was asking about what's due and what's not. So on Blackboard, when you build a class, you have a whole bunch of you might have a whole bunch of stuff in there. Like it might be 5 versions of test 1, but only one of them is going to count. But it'll add the points up as if we're going to take all 5 of those tests. So that's why I sent this out. Let's see. What's that? announcement. But if you look right here, yeah, it is right here. It's got all of everything that we actually are responsible for. I sent this out early, well, like way early, but I thought I resent it. I might have just done it for my 10 o'clock class. But yeah,
Okay,
so
because
all
that
of
includes everything that we're responsible for the
yes,
semester, right?
yes,
Okay.
yeah. So it's like, and so you can kind of, if you look at Blackboard, I went in earlier when I first opened the class up. I went in and tried to delete a bunch of stuff that I knew we weren't going to do, and just tried to concentrate it down to only the stuff we would do. But Blackboard is Blackboard, so that's why I went. That's why I made this list right here. I thought I resent it, but let me do that. I can resend it now. Let me just change the date, and then it'll send it again.
Dr. Russell,
Yeah, go ahead.
can you send out the recording for Wednesday? Or maybe you did and I just didn't see it, but I didn't see it in the email.
There's nothing. I didn't record Wednesday. Wednesday was just silence. We had like a breakout session, and then we came back, and it was just really quiet. So it was kind of a pointless to put that up. I have it. If you want it, I can post it, but it was real quiet. You could hear a rat pee on cotton Wednesday.
Okay, could you still send it out so I know like maybe what you guys went over?
Sure.
Okay, Professor, I'm gonna email you now about the quizzes that I missed.
Yep.
Okay, thank you.
All right. If there's nothing else, I'm gonna stop sharing. I might have to edit all this recording out. Shucks. Stop recording. Or did I already stop?